Hi and welcome to this new video tutorial. We're going to create today a new app where we're going to command the keyboard using our eyes. We're going to create this app in 3 simple steps. The first one, we're going to detect the eye, and when the eye is blinking this way, we're going to detect the gaze. So where we are looking at, if the top, bottom, left or right with our eyes. And this is the first step. Second step, we're going to create a virtual keyboard on the screen where we have all the letters from the keyboard. And finally, third step, we're going to link both these parts. The first one where we use our eyes, and the second one with the virtual keyboard, so that we can command the keyboard. For example, choosing the key by looking in some specific part of the screen, or pressing some key, blinking our eyes, for example, for a half seconds or more. We'll see that later. This app is really useful for people who are affected by quadriplegia, that they don't have any use of their limbs. Let's start right now and let's do that step by step. First, we import CV2, we import numpy as np, we load the camera. Cap is equal to cv2.videoCapture 0 if you have one webcam. If you have more webcams, it can be different indexes. It depends which one you want to use. Then while loop to load the frames from the camera, while true underscore frame is equals to cap.read. Let's show the frame. cv2.im show frame and then frame. Then wait key event, key is equal to cv2.wait key 1. If the key is equals to 27, which means that we are pressing the S key on our keyboard, we break the loop, we release the camera cap.release, and finally cv2.destroy all windows. Let's run the script, and if everything is correct, we should see just what we're detecting from the webcam. Let's now import a new library. This new library is called dlib, and I will put some link with installation instructions in somewhere in the description or in my website. And after you have installed the lib, you can follow again this tutorial. We're going to use the dlib library to detect first the face, and then from the face we're going to detect the eye. Let's import the lib, and first let's load the face detector. Detector is equals to lib.get frontal face detector. We're going to use this object later on the frames, and through this simple step we're going to detect the faces. So first, let's convert the frame in grayscale frame. Gray is equals to cv2.cvt color of the frame, and then cv2.color underscore bgr to gray. We're going to use gray frame because, as you should know, gray image, it's much lighter, and when we can, we have to use the lighter image to save some computational power. So let's even, and there is no point to show the gray frame now. Gray, and then let's detect the faces. Faces is equals to to the detector of the gray. That's all. And faces is an array where we have all the faces. So we print where we have, let's put it in better words, where we have, it's an array, we set another array where there are the points, the rectangle of all the faces. So for face in faces, let's print face so it will be more clear to you. I have some problem. Color BGR to gray. CVT color. I cannot figure out. Okay, I don't know what was happening. Here we see an array, and if you look carefully, when I move my face, the number changes. This is a rectangle with the first one, it's the top left point of my face somewhere here, and the second one, it's the right bottom. So if we, for example, print them, cv2.rectangle, not print, but if we draw a rectangle using these points, and we use x, y is equal to face dot left is the face dot left and face dot top left. So x is the face left and y is the face top, and then x1 and y1 is equals to face dot right and face dot bottom. We show the rectangle on the frame. Then from the frame we first point x and y, and then second point x1 and y1. The color, let's make it BGR green, and thickness 2. That's enough. Let's run the script right now. Let's see what we get. And this is the detection of my face. Let's move on. Now from the face, let's detect the eye. Using the lib library, we can detect 68 facial marks point, and I will show you exactly which ones. I have somewhere in landmarks point. Okay, I have the image. I will open it with another program so I can put it full screen. Landmarks point. Using the lib library, we are going to detect all these points around our face. So the eyebrow, the eyes, the nose, the mouth, and all the boundaries of the face, our jaw. We need only the eyes, so we need these specific points from 36 to 46. 36 to 46. But let's do that step by step. Let's go again on main. We don't need to see the rectangle. We don't care about that. We need to get the landmarks. Landmarks is equals to predictor. Predictor is our object that is going to find the landmarks. We're going to find the landmarks on the gray frame in a specific position, which is the face, because there is no point. Let's run this again. Oh, okay, I'm not showing the rectangle with the face, but we find the landmark on this specific area first. We detect the face and then we find the landmarks. There is no point to find the landmarks in all the image. Landmarks. Now let's load the predictor. Predictor is equals to the lib.shape predictor, and we need to load a file. The file is called shape predictor 68 face landmarks .dat, and you can download this file from the link in the description of the tutorial link. And then you need to put it in the same folder where there is your Python script. So you can run it just copying it this way. We detect the landmarks, and let's print it and let's see what we get. Print landmarks. Each landmark is an object, and each time is returning as some value. So let's go more into details. We can choose, I close the points, we can choose the points that we want to get, 0, 1, 2 and so on till 68. Let's for example draw the point number 36. Let's take the point number 36, so it will be landmarks dot part 36. Let's run the script, and it's going to take some time. And this is the position of the 36 point in my eye. Let's draw a circle around that point so it will be even more clear. Let's draw a circle right now. From these landmarks we have x and y. X is equal to landmarks dot part 36 dot x, and the y will be, you can guess, landmarks part 36 dot y. And let's draw a circle in this specific point. cv2.circle on the frame. The center point will be x and y, and the radius, let's make it 3 pixels. The color, let's make it red. 0 blue, 0 green, and 255 of red, and the thickness 2. We don't need to take these values anymore. I'm going to comment this part of the face right now. And let's run the script again. Let's see what we get. And you see the specific point 36 really precise. 36, you can compare the image with my image, and even if I move, it works perfectly. We could show all the points for the entire face, but we will make the tutorial only longer, and it's not necessary right now. So let's focus mostly on one eye. There is a way to detect when the eye is closing, and I'm going to show you that right now. Let's take a close look at the eye that I have here on Paint. On this eye, according to the landmarks points, we have 1, 2, 3, 4, 5, 6 points. So they are, let me draw them. Point, no, I want this one. Point 36, 37, 38, 39, 40, and 41. Let's draw a line, two lines, horizontal and vertical lines. Horizontal line from point 36 to point 39, and vertical line straight from the top to the bottom. So we can say that the line starts from the midpoint between the 37 and 38 at the top to the lowest part from point 41 to 40. We can find the blinking detection just looking at the length of these two lines. The horizontal line stays almost the same when we close the eye, while the vertical line where we have eye closed is almost close to 0. So we can compare, for example, we can divide the first one, the horizontal, with the vertical, and we can check the ratio. For example, now the horizontal is around, I guess, around 2 times longer. And we can see how this changes, and we will test it and see what will work best for us. Now, to finish at least with this video, let's see, let's draw this line. Let's first find these points and draw the lines. We can draw first the horizontal line from point 36 to point 39. So let's detect these 2 points. The circle, we don't need this x and y anymore. Let's detect first the left point. Left point is equals to landmarks dot part 36 x and dot x and landmarks part 36 dot y. The other point, the right point, is 39. So let's copy this one and let's call it right point. Right point is equals to landmarks part 39 and 39. Now that we have left and right point, let's draw the line. Horizontal line is equals to cv2.line. We're going to draw the line on the frame. The first point is the left point, the second point is the right point. The color, let's make it green, 0, blue 255 of green, 0 of red, and thickness, let's make it 2. Let's now restart the main script and let's see our result. And you can see that the detection is really precise. Even if I move the face in different directions, the horizontal line stays where it has to be. We now need to draw the vertical line from the top to the bottom. This one is a bit more complicated. It's a bit more tough, as we need to find the midpoint between 37 and 38 and the midpoint between 41 and 40. Let's find the midpoint. We need to use a bit of basic geometry. To find the midpoint, we need to sum both of the x of 41 and 40 and then divide it by 2, and the same for the y-axis. To do that, we're going to create a function, so it is going to simplify the work for us. Let's call the function midpoint, def midpoint. We pass 2 points, point 1 and point 2, and we return the sum of point 1 dot x plus point 2 dot x, and this must be divided by 2, and then the sum of point 1 dot y with point 2 dot y, and also this divided by 2. We need to keep in mind that as we are talking about pixels, the pixels cannot be float. For example, if x plus x is 501, we divide it by 2, is going to be 250.5. And the pixel cannot be half. Pixel is either there is a pixel, either there isn't, so it's going to be 250 or 251. That's why we need to put integer before, so all this part is going to be integer, and the same for the second, int and int. Now we have the function to calculate the midpoint. So to find the top bottom point, what top bottom? To find the center top point between 37 and 38, we need to pass to this function 37 and 38, and we're going to find this part in the middle. So we just do it this way. Center top is equals to midpoint. I think I did call it with midpoint. There is a typo, midpoint. Okay. Midpoint of landmarks. Landmarks dot part. I think it's 37. Yes, 37. And landmarks dot part 38. We do the same for the point below. Center bottom is equals to midpoint. I'm going to copy this one and just change the index of the parts. We have 37, 38 for the top, and then 41 and 40 for the bottom. 41 and 40 for the bottom. Let's now draw the vertical line. Line is equal to cv2.line. On the frame, we have from center top to center bottom, and then also this one green 0 to 55 0, and also for this one the thickness of 2. And let's now see the result. You can see, if I get closer, I'm looking there because I have my webcam on the other part, but you can see that it's really precise. So we can check the ratio between these two lines, and we really easily we're going to detect the blinking. And we're going to see this part about blinking detection in the next video. We're going to work with this with the ratio. And I'm going to stop the